Hello, I'm Mr. McBrien. This is TIJ10, Arduino 3, Variables, and more. Yesterday we talked about the structure of an Arduino sketch, talked about how to set up comments inside our code, and how to initialize output pins. Today we're going to talk about some more fundamental programming concepts, almost universal concepts, the idea of variables and loops. So what are variables? Variables, we can think of them as a specific bucket into which we put information. So it's a location for stuff we need in our program. And we name these buckets and then we put things in them. And later we retrieve those things when we need to. Okay, so what do we use these buckets for? Well, I'd invite you to ask yourself, what could you use information for? Information that may change at given times. Well, first off, we need variables to do calculations, to calculate a lot of different things we'll talk about in a few seconds. We need variables to be able to compare one thing to another, to decide if one thing is larger than another, for example. We need to be able to store sets of characters called strings and then output these as needed. We need them very commonly to use to keep account of the number of times we've done something. And then maybe something that is least intuitive to someone who's about math rather than programming, we need variables to store a state. So whenever we want to remember that we've done something or haven't done something or need to do something, we might store that information in a variable. Okay, so variable types, because we use these things, these buckets for different purposes, we have to have different kinds of buckets. So there are official types of buckets that we have to set up, and we'll talk about that also in a second. We have to realize why we're going to use a variable before we set it up. Think of it as we have to have a specific kind of bucket for a specific kind of container. So we can have characters, we can have bytes, we can have integers. We can have integers but that are not allowed to be negative. And we can have more classic numbers like 3.14159, for example. We can also have those classic types of decimal numbers that are not allowed to be signed. In other words, they can't be negative. And we can have other kinds of numbers as well. And as we use these types of variables, these types of buckets, we'll introduce them to understand better how we use them. Okay, so like I mentioned, before we can use a bucket, we have to actually make it available. Think of it as going to the hardware store and buying that bucket. Before we can use it, we have to do this thing called declaring it. And this is common across all programming languages. So we have to tell the Arduino at the beginning of the sketch the variable name, what kind of variable it is, and usually we'll give it an initial value. So we might set it equal to 0 at the start. And we will use almost exclusively in TIJ the idea of a global variable, a variable that is declared once at the beginning of the sketch, and then it is used anywhere we want in the sketch. Some other times we'll borrow a bucket. So we'll declare the bucket inside a specific part of the code, and then we'll give it back when we're done and we can't use it anymore. Okay, so we've already learned that we have to be very careful about the keystrokes, careful about the characters that are in a given line. The syntax for declaring a variable is in fact very simple. If we want to declare an integer, we give it a unique name, for example, input variable 1, and we of course leave that semicolon at the end to tell Arduino it's a command. We can also combine the declaration and what we call initialization, giving the variable an initial value. we can combine those into a single line. So we could have said the input variable is equal to 4 when we started it. We didn't bother in that case because we didn't need to. In the second case, we know we need input variable 2 to be 0 for our code to work. So we set it equal to 0 right at the beginning. And that setting of a variable is just done by putting an equal sign, and whatever's going into that bucket will be on the right-hand side. The variable names, almost any set of characters can be used as a variable name. There's just some specific ones that are commands that you can't use. And we'll learn what those are. But if you follow the rules based in these slides, you won't have any problem with that. Now we do have to remember that capitals matter. So if we have input variable 1 with capitals and input variable 1 without capitals, they are two different buckets. So we need to keep that in mind. Now, to get full marks and to build good programs, we use long variable names. We resist the temptation to have a variable name of X, even though we're going to see it in a few seconds. We're going to resist the temptation to have variable names of X and Y. And instead, we're going to have great big long variable names that communicate what we're doing. And this helps us with having our comments be less, and it helps us with remembering the names of and the purposes of our variables. So this is an example of a communicative variable name. Number of iterations completed. It's very clear what we intend to use that bucket for. And in fact, if you want to get best possible marks, you need to use these approaches. Don't forget, copy and paste means you don't need to type these things in. We have to be very careful to initialize variables. It's a common problem, even for more advanced programmers, to forget to initialize their variables. Lots of sketches won't compile if there's no value for a variable at the start. Lots of sketches will crash if there's no value for a variable at the start. When you declare it, usually you should just give it an initial value that matches your logic. Okay, the integer variable type we'll use a lot. The reason we use this number with no decimal, so there are only whole numbers allowed, the reason we use it is usually for counting. And counting is a very common thing to do in programming. For example, we might want to move 4 objects. Well, we keep a count of those objects, and we know that we can stop as soon as we've moved the 4 of them. Now, in contrast, we can have real numbers that have decimals and negatives and things like that. So for decimals that we don't need to worry about negatives, we can use an unsigned long variable. For decimals that might be negative, we can use just the long variable type. And there are other kinds, but we'll figure out when we need those as we go along and we get better at programming. Now, in terms of doing calculations, we'll often have to do calculations for various purposes. We might want to calculate the distance to something. We might want to calculate the speed of our robot, for example. We might want to calculate the temperature from a sensor input. There are lots of reasons to do calculations. Calculations are very simple to do. We usually will have a real number, so a long number or an unsigned long number, to which we assign the result. So the syntax is very simple. We just make the result some variable. So here's an example of a calculation command. Calculated value equals value 1 plus value 2. And the only thing you need to remember is that the calculation must be on the right-hand side. It's not like in math class when you can have the opposite order. That doesn't work. So we can, of course, have subtraction as well. Multiplication is the asterisk, and division is the slash. So for more sophisticated calculations, if it turns out you need them, you can look up those in the references. All right, so for our first activity, what we want to do is just take any existing working sketch we have, and we're going to add some code. We're not even going to be able to see it work, but that's no big deal. What I want you to do is at the top, declare a global variable, an integer, and I want you to declare an unsigned long second variable, and you can name them anything you want. Then inside your setup code or inside the loop, you can set a value for the integer and then use it in a calculation. So you're going to add 4 lines to your existing sketch. And just to reiterate, because we don't have any print command in there, we're not going to be able to see the output of our calculation. We're going to have to live with that. All I want you to do for now is just confirm that your sketch compiles successfully. Okay, now let's have a look at part 2. We're going to look at how to create loops inside the Arduino software. Now, you might say, wait, we've already learned how to do loops. We just have to put any command we want to execute over and over again inside the loop structure in our sketch. And that is true. However, in some cases, we need to have a loop execute a specific number of times. And if we put our code inside the loop section, it's going to keep executing forever. So the question is, what happens when we want an activity to stop? Well, the good news is that virtually every programming language has a capacity for this kind of thing. It's called a for loop. So a function can be performed a specific number of times. In the Arduino, we can execute this for loop with this kind of structure right here, where we have, in this case, we're going to print x, the variable x, as the loop is executing. But notice that x is a counter, and what we're doing is taking this integer x and going from a value of 0 up to a value of 99. Not 100. Notice that it's not 100. It's less than 100. And this thing here tells it to increment by 1. So each time it changes by 1. So this for loop structure is very common across many programming languages. And it gives us a new way to execute a series of commands efficiently. Notice that we've only got 2 lines of code here. Notice we've only got 2 lines of code here, but in this case it'll execute 100 commands. Okay, so we will learn how to use that loop then in our assignment. Key points from today then. Variables keep track of numbers, situations, these kinds of things. They're buckets to keep our stuff in, to keep our information in. We have to have specific types of variables that match the application. And in order to be able to use these variables, we have to declare them and initialize them at the beginning of the code. Now we've also learned that loops don't necessarily run forever. Some of them we want them to run a specific number of times and stop, and we have a structure for this called a for loop. It uses the counter variable, that integer type, to run a loop for a certain number of times and then stop. Okay, for your homework today, I'd like you to do the exit card, and then in your assignment you're going to implement a for loop, and you're going to see how to put in place the structure for this. Here are the references for what we've done if you want to do any more reading on it. Thanks very much, and have a great night.